Good afternoon, everyone, and welcome to the roof framing webinar. My name is Nick, and I'll be doing the presentation with you today. Just like all of our webinars, everybody will be on mute, but if you do happen to have any questions at any point during our class, please feel free to go ahead and type those into the questions and answer section of the Zoom panel. And at the end of the class, I will go through and answer any of the questions that may have come up. Also, at the end of the class, I will be sending out an email that's going to contain a document that covers everything that we're going to be looking at in today's class. Should you happen to have any questions about anything that we're covering in that document, you can contact our support department and they will be happy to help you out. Again, today's class is on roof framing. And in today's class, we're going to be looking at how you can modify a roof's framing information to represent exactly how you want that roof to be framed. The roof can include hand-framed or rafter framing members, truss profiles, or it can just be a timber frame truss. We're going to go through and we're going to be looking at how to add and modify the roof rafter framing elements associated to a roof. We're going to be looking at how to insert a truss profile run. And then we're also going to be looking at how to insert timber frame trusses for a selected area or for individual insertion. So first, let's talk about roof rafter framing. Roofs have a framing configuration assigned to them that you see when you display your framing. Framing can be displayed using the display framing tool and is included in the project estimate. Settings in the framing configuration let you specify whether or not you want each component in the roof frame to be displayed and quantified. You can assign a member type, a usage, and a phase to each member in the configuration. We're going to go in and we're going to add in a roof onto this rectangle into our drawing. So what we're going to do is we're going to go up and we are going to go in and add in a roof. So I'm going to select the roof option, and then I'm just going to grab a 612 slope roof, and I'm just going to left click once in the middle of that design, and that's going to add in my roof. Now what I want to do is I want to start to adjust the properties. So I'm going to select the roof, right click, and I'm going to go into the properties of the roof itself. When you open up the properties, you can see that you get the roof's dialog box. And as you can see, mine says document because again, I inserted this roof into a drawing file. When I'm accessing it to adjust its properties, I'm doing that at the document level. We can see that it has a name, and the roof that we inserted was a 612 slope hip roof with shingles. We then see that this is on the basic tab. Now on the basic tab, this is where you have a lot of the different controls. So you can adjust a lot of the different properties for that particular roof using the basic tab. You're going to be able to adjust the parameters, so the slope value. You're going to be able to adjust how you want the slope value to be determined. So when we say slope type, by default, we do a rise over run, or you can do a degrees or percentage. Again, whichever is going to be more common for you in your region. Once you've defined your slope type, you then have the option to adjust the thickness. Now, the diagram on the left-hand side gives you a legend of everything that is being called out here. So here you can see that the thickness is going to be the total thickness of the roof. So that's going to be the rafters plus whatever the thickness of the surface is going to be. So here we're saying 8¼ inches. We have an overhang of 16 inches. So 1 foot 4 inches is what we're using there. We have an overhang drop, which is going to be how far the bottom of that fascia sits below the top of our wall. And here we can see that that is going to be set to 9¾ inches. We have our fascia distance, which is going to be the height of the top of the fascia to the ground itself. So we can see the E value there, and that's going to be set at 8 5/8. We have the F value, which is going to be the horizontal distance. This is going to be the distance from the edge of the wall to the next bearing point, which will be the ridge in our case. Then we have the vertical distance, and that's going to be calculated using the G value here. And here we can see that the G value is set to, again, 3 foot 3 3/8. A lot of these values will adjust depending on the variables that you're editing. So some of these values may be adjusted automatically for you as you start to edit other fields. And that is by design. It's going to do all the math for you. As we scroll down, we're going to see that there is also a G value, which is going to be the vertical distance. Again, so that's going to be the height there we just talked about. And then H is going to be the surface thickness. So how thick is that surface going to be? This will include the sheathing and whatever material you're using for the roof. We're using a shingled roof here, so we're just giving it a thickness of 1/4 of an inch. And then we're going to have basically a 3/4 inch to 1/2 inch thick sheathing material. Underneath all of that, we have the specify framing. And when you click on the specify framing option, it's going to bring up the roof framing dialog box. Now, in this dialog box, you have the ability to control the exact members that you want to use for each component of the roof framing. It's going to be broken down into each heading for you. So you're going to see rafter, opening header, fascia, ridge, hip, and so on through that list. And then in each of these, you're going to have not only an include and framing option, which is going to be a yes or no option, but you also can control the member, the usage, and the phase, and then any other subsequent measurements that you need. And in this case, for the rafter, you're going to need spacing. This allows you to, again, exactly pinpoint exactly what members you want to use for the different parts of your framing. So the rafters are going to be using a 2x8. We're going to have a usage of rafter. As you can see, we may have a 2x8 somewhere else in our design. So when I look at my report, I want to be able to determine very quickly what was that 2x8 used for. By having a usage, you're going to be able to distinguish that. Because you'll see 2x8, you'll see the usage, and in this case, that 2x8 is a rafter. This 2x8 is a ridge beam. So that's the importance of specifying and using your usages. It just, again, helps you with the organization in your quantity reports. Same is true for the phase. This is also going to be helpful for when you want things to be delivered to site. So this will allow you to specify, in our case, a roof framing phase. You're going to have a wall framing phase. You're going to have a basement construction. These are different phases that helps with the organization of the materials and when they need to be delivered to your site. As you scroll through this dialog, you're going to see that there are a lot of different options. You can, again, include a lot of framing in your designs, and you can also turn certain things on or off using the yes and no dropdown. As you get further down, you're going to see that there is a gable ladder option. So if you are inserting a gable end roof and you want to show the gable end framing, so the gable ladder, you can adjust exactly how you want that to be specified. It can extend to the structure, which will be to the wall itself, or you can specify a fixed distance. So if you want the ladder to extend over the wall to the next rafter behind it, then you can specify a fixed distance by typing in its value. Again, same is going to be true in here. You're going to have, again, your usage and your phase, and then any subsequent measurements that you need, in this case, spacing for the gable ladders. We can add in collar ties, rafter ties, purlins, and batten information to a roof. Again, the importance to this is, again, including a lot of the members that you're going to be using for roof framing so that they show up in your quantity reports. I'm going to click cancel on there. I don't want to make any changes to that. And then we're going to click on the support and details tab. Now, on the support and details tab, this is where you're going to be able to control some of the values of how the support is going to be specified for the particular roof that you're using. By default, we have our roof type set to rafter. So we're doing a stick framed roof here. You can use the drop down, and if you take a quick look at the variables that you see underneath that, we have a support height, we have a raised heel, a bird's mouth, and a seat. Depending on the support type, these values will be grayed out or turned on for you. So with a rafter, we're going to have a support height. So how high are we supporting this roof on our wall? And our walls are 8 foot 1 1/8, so that's where we're going to be supporting that particular roof. And then we have a bird's mouth and a seat option for a rafter. This is again just going to be the cutouts of the rafter to help with the support of where it's going to bear on the wall. So the bird's mouth again is going to be the notch that is cut in the lower end of the rafter to fit it to the top plate of the wall. Where the seat of the rafter, this is the horizontal cut that is made when cutting a bird's mouth in a rafter. And you can adjust the values here for the bird's mouth and seat according to the size of the rafter you're going to be using. If I switch this to be a truss, what's going to happen is we are no longer creating a bird's mouth or a seat. We now have a bottom chord that we're potentially using. So that's going to be our height for that particular for that particular truss. So we're going to be able to, again, adjust the support height where it's going to be sitting to the bottom chord, or we're going to be able to, again, adjust the raised heel height. And this is going to help us, again, with the dropping of that truss within our design. Underneath all of that, we have our fascia option. And then here you can control the fascia depth. You can control if it's going to be a plumb or raked fascia. And the same is going to be true with the soffit. Do you want the soffit to be plumb or raked with the roof? By default, these will be set to plumb. I'm going to change this back to rafter. I'm going to say OK. And I'm just going to go into my gable ends. I'm going to go into the properties. And I'm going to specify these to be gables. I'm going to go back into the specified framing. And I'm going to turn on the gable ladder framing. I'm going to say yes to that. I'm going to leave it to structure. We're going to leave it at 2 foot spacings. And we're just going to use a 2x6 for this option. I'm going to say OK. And then OK. So what we're going to see, if I turn on my framing options, we're now going to see my gable ladder framing to the structure. And the structure here is the wall itself. Now, if I go back in and I turn off all but framing, if I select the gable ends again, I go back to the specified framing, and I take a look at the gable ladder framing option again. And instead of saying to structure, let's just say I want that to be a fixed distance. And I want that fixed distance to be 3 feet. I'm going to say OK. What's now going to happen is it's going to ignore the structure and it's going to extend the framing all the way back. So now when I go into my gable frame, or sorry, into my roof framing, I'm going to see my gable ladder is now extending over my structure, over my wall, and it's tying into the next rafter back. And in a 3D view, it will look like this. And I'm just going to turn on rendered outline so you can see it a bit clearer. And that is the option for applying your gable ladder framing. I'm going to go back into 2D and go back into display all but framing. And the next thing we're going to be looking at is adding in a truss run. So you can use the truss run tool to quickly insert a run of truss profiles under an existing roof surface. The tool will recognize the hips, the valleys, and the gable ends of the roof and insert an appropriate profile. It also recognizes any ceiling surfaces beneath the roof and will alter the profile of the bottom chord to accommodate them. So let's add in a ceiling really quick into our design. So we're going to go in, we're going to drop in a ceiling. So go ceiling by room. It's going to use a 1/2 inch drywall ceiling. I'm going to drop that right into the middle of my design. That adds in the ceiling. You may not see it right away, but when we use our cycle select, we can see that it is now selected. We can also go into a 3D view if we wanted to, and we can just walk inside and we can select the ceiling, go back into 2D and just go edit, select previous, and it will also bring up the ceiling. But we're going to create a cathedral ceiling. So we're going to go right click, properties, and we're just going to say cathedral. We're going to say okay. I'm going to change the ends to be my cathedral. So I'm going to go right click, properties. We're going to adjust this edge to be a gable edge. I don't want a skirt width on there, so I'm going to make that 0. I'm going to say okay. And then I'm going to do the same for the other sides, but I'm going to keep them as a hip. I'm just going to control the slope, and I'm going to get rid of the skirt on this side as well. So I'm going to go back into properties. I'm going to get rid of the skirt, and I do want that to be straight. Instead of using degrees, I'm going to use the rise over run. The main roof was a 612, so I'm going to make the interior side here, I'm just going to make it a 312. This will keep it at a lower slope than the roof, so when I add in my truss run, it will cut the trusses at the same angle as the roof. So, or as the ceiling surface, sorry. So we're going to say okay to that. And again, just so you can see what we're working with in 3D, we have a ceiling surface. And if I pan up, we're going to have a void, and that is going to be where we're going to add in our truss run. So we go back into 2D. And now what we're going to do is we're going to go up and we're going to select under insert roofs. We're going to select truss run. Under truss run, we're going to select the think truss, and we're going to basically just select one edge of the wall, and we're just going to drag this down so that it meets the opposite edge of the wall. Just like that, we've added in a truss run. And if I go into a 3D view, we can now see that those rafters, or sorry, those trusses have now been cut to match the slope of the ceiling. I can select the ceiling and I can elevate it up or down. So if I want this to be 7'11.5 inches, it will bring that down that 1/2 inch, and we'll be able to see how that looks. I'm going to go back into 2D. We're going to be next looking at the timber truss option. So you can use a timber frames tool to add trusses to your model as well. Truss types include the scissor truss, the tray truss, and the attic truss. When inserting timber frames, you can insert a single frame or a series of frames that span a specified distance. The catalog contains a variety of trusses and portal frames that you can customize to suit your needs. Now, the one thing I do want to point out here and make note of is Envisioneer is not a structural analysis program. So the trusses that we're adding in are just geographical representations of a truss. These are not engineered trusses based off of the loads or the spans that you're using. That is something that you will need an engineer to do. These are just used to help give you a graphical representation of where the trusses may need to be in that particular design. So let's add in a timber truss run into our design off to the side. So what we're going to do, again, in our plan view, we're going to go up and we're going to select under insert. We're going to select under members. We are going to select the insert timber frames. When you select the insert timber frames option, the catalog on the right-hand side is now going to populate with the different truss types that you can use. And as you can see, there is a scissor truss, a tray truss, an attic truss. We have a mono truss, a think truss, and a flat truss. Underneath the portal frames, we have a pole barn option that you can use to create your pole barn framing. We're just going to use the think truss for right now. Actually, let's just use the scissor truss. And I'm going to bring my mouse into my drawing area. Now, in the lower left-hand corner, you can see that there is a base height option. You can use this to, again, insert the height of the framing that you want for the design. I'm going to leave it at 0, and I'm just going to left-click once. What that does is it now starts my truss run. So I'm basically telling it I'm starting my truss run from here, and I want it to go either down, up, left, or right in my drawing. I'm just going to move my mouse down. Again, the commander is active. I can type in a set distance if I want to, or I can just be freeform and pick wherever I want. I'm going to type in 25 feet, and I'm just going to hit enter. What that will do is it will now add in the trusses at that distance. Now, what I have to now specify is, what did that line represent? Was that the center of the truss? Was that the left-hand side of the truss or the right-hand side of the truss? So you can adjust exactly where you want to place those trusses based off of the points that you selected. I want that to be the center, so I'm just going to left click one more time, and that adds in my truss run. Oh, sorry, my timber frame. Now, what I can do is I can go back in, and I can go back into the properties. And again, since it's been inserted, it's a part of the document. And I can fine tune the actual adjustments for the trusses that I've added in. So here we're saying that the support height was 6'6 3/4. I can say I want that to be 8 feet. I want the spacing to be 2 feet between trusses. I want the bottom cord position to be at a set height, so I can see the the height is going to be 6'8". That's not the bottom cord, pardon me. That's bottom cord to the peak, so that's going to be 6'8". That's again going to be based off of the size of the truss. So here we're saying it's an 8/12 slope. If I change that to be a 6/12 slope, it's going to adjust for us. So it's going to do the math for us automatically. If the span changes, then the height will also change. So if this is a 25-foot building, then it's going to adjust the actual height of the trusses. So again, you can play around with these values. Again, fine-tuning exactly how you want things to be laid out. We can say I want that to be 15 feet, and that's just going to help with the bottom chord of where we want the piece to be for our design. Here we can again, D1 is going to control any kind of a webbing material that we want in here. I can just say 1 foot for that, and it will again just start to fine tune how this is going to look. And you can also specify the framing member that you want to be using for this truss. Again, I can't stress this enough. This is not a structural element. This is just a graphical representation. So you're trying to make this look as close to possible as to what a rafter or what a truss would look like in your design, but you will need an engineer to do the actual truss manufacturing for you. Once you're happy, you simply just say okay, and then all the changes you've made are now going to be applied. And when you look at that in a 3D view, if we pull our camera out to the side here, we will now see that truss run showing us our timber trusses all the way through our design. You can also insert single trusses in your design. So if you wanted to just place trusses in automatically, you can just go up to and select under members. You can say insert a single truss. You're going to get the same catalog where you can select the individual trusses, and then you can actually just place in a truss wherever you want. And in this case, you're controlling the actual size. So if I specify my first point, I'm now going to be specifying the width. So what is the actual span of that truss? So I'm going to pick the direction. I'm going to move it in the direction that I want, and then I'm going to type in the distance. I'm just going to say 25 feet and hit enter, and that truss is now 25 feet. And that's what the span of that truss will be. And once again, you can select that truss after it's been inserted, and you can fine tune the height, the slope value, all the different variables that make up that particular truss, you can adjust. So that covers everything that I wanted to talk about in today's class. I'm going to go ahead and open up the questions and answers period of our class. So if you do happen to have any questions, please feel free to go ahead and enter those in. While you're doing that, I'm just going to, again, just go over a quick review of what we've covered in today's class. So today we went through how to insert roof framing and how to control the framing for the particular roof options that you have available to you. The default parameters for a roof will be controlled in the properties of the roof dialog. So you can control not only the members, but the shape of the roof as well. Adjusting the members, again, is going to be underneath the properties of the roof. So you double click on a roof, you can control the specify framing option and isolate exactly what members you want for each individual component of the roof. We also give you the ability to add in truss runs, which will allow you to add in a truss run through a design. This truss run will recognize the roof surfaces, and it will also recognize any ceiling surfaces that you have, and it will cut the truss accordingly. We then looked at the timber profile option where you can actually insert timber framing, and it's going to give you a couple of different truss options. Those being your scissor trusses, your tray trusses, your attic trusses, and so on. And these are going to be inserted with a 3-click process. You're going to specify your start point, specify your end point, and then click in the direction that you want the truss to go. So is it from the center, from the left, or the right? And then we looked at how to insert individual truss options using the truss option underneath members. You can insert a single truss frame. So at the end of today's class, I'm going to be sending out an email that's going to contain a document that covers everything that we looked at in today's class. Should you happen to have any questions while going over that document, again, please don't hesitate. Reach out to our support department. They will be happy to help you out with any of your questions. I want to thank everybody for attending today. I do look forward to speaking with you all again very soon. Thank you very much, everybody, and enjoy the rest of your day.